Hello and welcome. I am and today's topic is section of solids. So let us begin. So first, types of cutting plane or section plane. So here in section of solid, we will be having solid as our three-dimensional object, and we will be cutting the solid by different kinds of planes. So let us first understand how many types of cutting planes or section planes are available to cut this kind of solid. So let us see. So first cutting plane is nothing but a horizontal cutting plane. So as you can see figure here, so if we are having one cone, and if we try to cut the cone by a horizontal cutting plane, then we can have a circle generated. So horizontal cutting plane means a cutting plane parallel to earth's surface or earth crust is known as horizontal cutting plane. Or, in other words, you can say that your cutting plane parallel to your horizontal plane or HT is known as horizontal cutting plane. Now let us move to a next cutting plane. So it is a vertical cutting plane. So a cutting plane which is perpendicular to your horizontal plane is known as your vertical cutting plane. So let us try to cut this object, our cone, by a vertical cutting plane. When we try to cut the cone by a vertical cutting plane, the section will look something like this. And whenever we try to take the front view, it is seen in the front view. So now let us move to our next cutting plane, the profile cutting plane. So cutting plane parallel to your profile plane, which is perpendicular to your HT as well as DP. So such type of cutting plane is known as the profile cutting plane. So here we have cut our object by a profile cutting plane, and as you can see, whenever we try to cut our object by help of a profile plane, the true shape of the section can be seen inside, right? So now let us move to most important planes which we are going to use throughout this chapter. So first, AVP, auxiliary vertical plane. So auxiliary vertical plane means a cutting plane which is making a certain degree of angle with respect to your vertical plane is known as your auxiliary vertical plane. So let us suppose this is our cutting plane and it is making certain angle with your vertical plane somewhere here. So this kind of plane is known as your auxiliary vertical plane. So when you try to take the front view from this direction, you could have the actual section of your solid seen from this direction. So now let us come to a final plane, which is what? Auxiliary inclined plane. So a plane which is making a certain degree of angle with respect to HT, as you can see here. So this kind of plane is known as your auxiliary horizontal plane, or you can say auxiliary inclined plane. But remember, we are not using the term auxiliary horizontal plane because in practice it is assumed that whenever the plane is inclined to any surface, and if it is not given whichever surface is inclined, it is always assumed that it is inclined to your horizontal plane. So that's why this plane is not called as your auxiliary horizontal plane, but it is known as auxiliary inclined plane. Now, one more thing. So this plane was your auxiliary vertical plane. So auxiliary vertical plane is always perpendicular to your horizontal plane. So as you can see, it is perpendicular to your horizontal plane. While in the case of your auxiliary inclined plane, this auxiliary inclined plane must be perpendicular to your plane, which is nothing but what? A vertical plane. So always remember, auxiliary vertical plane is making certain degree of angle with your vertical plane, but it is perpendicular to your horizontal plane. While for the case of auxiliary inclined plane is making certain degree of angle with respect to your HT, but at the same time it is perpendicular to your vertical plane. So you should remember each of the 5 cases of your section plane or cutting plane. By keeping these cutting planes in mind, you should solve the example based on section of solid. So now let us proceed. So in our examples, we will be replacing the element by a different kind of element in the place of your cone in this case. So we will be just replacing cone by different kind of elements in examination. we need to solve the example for that, right? So now let us go ahead and let us see one of the examples based on your section of soil. But before moving to the example, let us understand a few of the important terms associated with sectioning of an object. So now let's suppose I have an object which is nothing but your square pyramid. So square pyramid once again is a group B object in which it will be having one base of any shape, square, pentagon, hexagon, any of the shape can be possible in the base. And it will be having a top point which is known as apex, and each of the base points will be connected to that top point, and you will be getting triangle into the front view, and you will be having in the top view your true shape of the section. This is nothing but what? A square pyramid. Now, when I try to cut this square pyramid by this red line, so red line is nothing but what? It is your cutting plane, or you can say section plane. So when I try to cut this solid by a red line, we'll be having one cut section generated into its top. So this is nothing but a cut section generated. So whenever the section is cut by a cutting plane, you should specify hatching or a special kind of a pattern by inclined lines, multiple inclined lines parallel to each other at some particular distance apart. So these lines are nothing but known as the hatching lines. So you should show the portion of cut surface by this hatching line. Usually the hatching lines are drawn at 45 degrees and they are placed at certain equal distance. So this particular portion is known as your section plane, or it is also known as apparent shape of the section. Now, so this was first your cutting line. This was the apparent section. Now after that, the portion is cut from the figure. So we should highlight the remaining portion. And the remaining portion after cutting the object is known as a sectional top view. So we try to cut our object, and then after we have taken the top view from this top direction, when we are looking from the top direction, we can have this image generated. So that's why this image is known as your sectional top view. Now, is it your true shape of section generated? No. So whenever you try to cut an object, the true shape can be generated only when you try to visualize or try to look your object at 90-degree direction to your cutting plane. So here suppose I have cut the object by a 45-degree line, and I should observe this object by 90 degree to this cutting plane line. And when I try to observe the object from my 90-degree or perpendicular direction of a cutting plane, then I can have a true shape of section generated on the soil. So let us observe this object from the 90-degree direction to your cutting plane in order to have a true shape of section generated. So this is nothing but the shape which is actually generated at the top of your surface of your square pyramid, which is nothing but known as a true shape of section, or it is usually known as a true shape. So these two images are nothing but your cut section, but this section is not an accurate section when it is looked from the top. So we need to observe this section from the perpendicular direction to that cutting plane, and when we try to observe this section, it will give us the exact actual dimension of this section. It will give us the exact and actual dimension of the section. That's why this is known as your true shape. So in examination it would be said that you will be having one object with a certain dimension. It would be either based on HP or based on VP. So you should first construct and solve the example for projection of soil. Thereafter, the second stage, what you need to do, you should take one cutting plane based on your problem statement. So here suppose I have given this cutting plane, so I should put the cutting plane at the prescribed position. And after putting that cutting plane, I should develop this cut section into my another view. And then after it is asked that you should generate the true shape of the section, then simply I should draw 90-degree lines for my cutting plane, and I can generate this shape, which is nothing but a true shape of a section, right? This will be our procedure to solve any of the example of section of solids. So now let us begin with the very first example in order to get a clear idea of what I am saying. So let us solve very first example based on section of solids. Problem number 1. A square pyramid base 40 mm side and x is 65 mm long as its base on HP and all the edges of the base are equally inclined to VP. It is cut by a section plane perpendicular to VP and inclined at 45 degrees to HP and bisecting the axis. Draw its sectional top view, sectional side view and true shape of the section. So this is our data. So let us first analyze the data. So here we say that a square pyramid, that means our object is square pyramid like we have seen previously. So we will be having pyramid. Pyramid means you should remember the Egypt pyramid. So the shape would be like that. You will be having one base. So here square pyramid, that means you will be having square as our base. And then after we will be having one top point which is known as your apex point. So each of the corner points of your square must be connected with your apex point. So you have the dimension to create your square pyramid. So now you should place your square pyramid as we said, it is resting on one of the edge on HP by having each of the sides equally inclined to VP. So we should construct square in such a position. Then after we say that we are having one cutting plane which is perpendicular to VP and inclined to HP at 45 degrees. So here the plane is given which is inclined to HP. So whenever the plane is inclined to HP, we can have a plane which is widely known as auxiliary inclined plane. A cutting plane which is inclined to what? HP. So here theta is given which is the inclination of your plane with respect to HP. So we should take AIP, auxiliary inclined plane. Now, then after, whenever the plane is given, the position of cutting plane must be given. So where to put that cutting plane in order to cut the object? So here it is said that your cutting plane is passing or it is bisecting the axis. So you should find out the midpoint of the axis and at that point you should construct this cutting plane. And after that it is said that few of the views you should draw. So which are the views you should draw? So let us see. So here first is your sectional top view. Second is your sectional side view and third is your true shape of section. So here we are talking about top view, side view, front view obviously we should draw. So we will be having three views, front view, top view and side view and then after finally we should construct the true shape of section for that object. So now let us begin our example. So first we should construct XY line. So let us construct our XY line. So now this will be our XY line as you can see. So the portion above your XY line would be vertical plane as you know and portion below this XY line would be what? Your horizontal plane. So now then let us proceed. So first we will place our object as it is said into your example. So it is said that it will be a square pyramid of base square resting on one of the edges in HP, that we should put the true shape square into HP itself and we should draw the square in such a way that each of the sides of the square must be inclined to a vertical plane by the same angle. So that means you should put the square resting on corner, so in which each of the sides will be inclined to your vertical plane by 45 degrees. So let us see how to put the square into your object. So this is the way we should put our square into the object. Now let us draw the 45 degree line which is showing that each of the sides would be at equal degree angle 45 degree with your VP. So let us draw our 45 degree line first like this. After drawing this line at 45 degree, you should put the line of the dimension equal to your square. So what is the dimension of your square? We say that base of 40 mm size. So that means we should draw a dark line of 40 mm onto that 45 degree line. Then after we should draw one horizontal line from bottom point and one vertical line from the top point. Then after we should be having one center by taking that point as a center and taking the end point of one of the lines as your radius. Draw one circle with having that dimensions. So you will be having one circle generated. After having this circle, you should be drawing your square by just extending the lines until you reach the circle's end point. So this is how we can generate our square which has all of its sides equally inclined to your vertical plane. Right? Thereafter let us draw the diagonal points of your square like this. So when you try to draw the square by its diagonal points, we will be having one center point generated which is nothing but showing your apex of an object. So our object is what? Square pyramid. So we have got the apex of your square pyramid at the intersection point. Then after let us give the notation or numbering of this square starting from A, B, C, D. So we will be giving this numbering as A, B, C, D as you can see. Thereafter we should give the center point as O. Now this is our final top view of an object. Thereafter we should draw vertical lines from each and every point, and we should try to produce our front view in vertical lines. So let us draw vertical lines from each and every point until we reach the XY line. From your XY line you should construct the axis. So we should draw one axis height from the center. So here it is given that axis is 65 mm long. So we should construct axis height 65 mm from your XY line like this. After having your axis, you should simply connect the top point of your axis to your points on your XY line, and you will be having one triangle triangle. This is nothing but the front view of your square pyramid. After getting your front view, you should give the notation to this pyramid. So let us give the notation. So A dash, B dash, B dash, and C dash. These are the notations for the front view. Then after let us give the notation to your apex point as a notation. Then after it is said that it is cut by a section plane perpendicular to DP and inclined at 45 degree to HP. So as we know that this is your XY line and below this portion is what your HP. So if your line is inclined to the HP at 45 degree, that means your line should be inclined above your XY line like this at 45 degree. But here in our case, it is cutting your square pyramid from the bisecting point of the axis. We should first find out the midpoint of the axis, and from that point we should construct one line which must be at 45 degrees to HP. So let us first find out the bisecting point of an axis. So this is your bisecting point of an axis. Then after from that point you should draw a line in such a way that it should be making 45 degrees with your XY line. So you should put on your roller scale or on your drafter a 45 degree set square. Then after putting your 45 degree set square, you should adjust your set square in such a way that it will give you one line which must be at 45 degrees to your XY line like this. So this is nothing but our cutting plane. Now cutting plane is shown by a special kind of line as we know from our previous chapters. So this is the way we can show the cutting plane line. So cutting plane line is long edge chain line, thick at ends as you can see and thin as well. So its ends should be a thick line and it should be thin as well. So this is nothing but your cutting plane line. Now let us observe. Whenever your cutting plane line cuts an object, you will be having number of sides cut by the cutting plane. So here let us observe how many number of lines this cutting plane is actually cutting. So here it is cutting O dash A dash the first line, then O dash B dash and O dash B dash, and finally it is cutting your O dash C dash. So here the cutting plane is cutting a total of 4 lines. That means 4 points will be generated on these lines by cutting plane. So let us define these 4 points. So first point we will be defining here like this. So let us start with the O dash A dash. Starting with the first alphabetical letter A dash. So O dash A dash line will be having the first point which is known as 1 dash. Then let us define the second point on O dash B dash as a 2 dash point. Then after B, what comes? C. So O dash C dash will give you a third point which is B dash, and then after we should come back O dash B dash and we will be having a 4th point. Always remember, you should give your cutting plane numbering in alphabetical letters only. If you are making a mistake in placing your numbering, you will be having incorrect answer in your examination. So always remember, you should follow a certain pattern while giving the numbering to your cutting plane points, right? So so we have got a cutting plane generated into our front view. Now we know that we are having total of 2 views. So we should transfer each and every point onto your top view in order to show the effect of your cutting plane into the top view. So let us transfer your cutting points into the top view now. So as you can see, we are having 1 dash point onto O dash A dash line. So we should transfer 1 dash point vertically on OA line. Then after we are having 2 dash point onto O dash B dash line. So we should vertically transfer your point 2 vertically onto the line OB. Then after we are having the third point which is on O dash D dash. So we should transfer this third point onto OC line in top view. And finally we will be having our fourth point which is on what? O dash D dash. We should transfer that point to the line OD into the top view. So let us start transferring the points. So now let us try to draw the vertical line from your 1 dash point. So we will be cutting OA line somewhere on this top view. So after getting this cutting, we should mark this point. This would be your point number 1 onto your OA line. Then after we should draw the vertical line from your C dash point like this. And then after we should mark that point as somewhere on OC horizontal line. Now let us try to transfer the points 2 dash and 4 dash onto OB and OD respectively. So now as you can see, if we want to transfer these points vertically, there is no horizontal line of OB and OD because OB and OD lines are itself a vertical line. So it is obvious that we can't transfer the points onto your OB and OD line. We can't transfer the points onto OB and OD line because these lines are vertical itself. If we are having the horizontal line, we can easily transfer the points, but here in our case, our lines are itself a vertical line, the point is just above that line, so we can't define that point onto the vertical line, right? So we should find out a way in order to transfer the points to that line OB and OD. So what to do? So let us observe the process very carefully because this is the main important point while in the case of your pyramid. You should follow these particular important steps in order to solve any of the examples based on section of solid of any pyramid. So now what to do? So we should draw the horizontal line to the next inclined line of an object in the front. So let us draw the horizontal line into the object to the next inclined line. So whichever the line you can choose is completely on you. So I am choosing this line O dash A dash. So after getting this point, so now our point is in what line? So our point we have transferred onto your O dash A dash line. And we know that we are having OA line horizontal down there. So we can easily transfer this point onto OA line. So let us plot this point now on OA line because our point is now on O dash A dash line. So now we are having a point on OA line. But let us ask ourselves, this point belongs to OA line? Yes or no? No, right? This point only belongs to your OB and OD line, but since it was not possible to transfer this point, you have transferred this point for simplicity onto your OA line, and thereafter we have plotted this point. So what to do? Don't worry. So now we should give the point back to the lines of which this point belongs to. So we should take our rounder. So take your rounder. Then put your rounder at the center point over here into the top view. Then take the radius is equal to center point O till your red arrow onto your OA line into the top view. Then by keeping that radius into your rounder, you should draw two arcs like this. So you will be having 2 points transferred onto your OB and OD line respectively. So now your point is finally transferred to your OB and OD lines. Then after we should just identify that points by darker points, we will be having these points. After getting this point, you should give the number to this point. So let us give the number. So on OA line point would be 1, on OB line point would be 2, on OC line point would be 3, and on OD line point would be 4. So let us give numbering 1, 2, 3, 4, right? Then after having this point, you should connect these points in your numerical order 1, 2, 3, 4. So let us try to connect these points. When we try to connect this point, we will be having one object generated. And remember, we have cut our object into 4 points. That means our object will be generated, which will be having 4 different points. And when connected, it will give one polygon of 4 sides, as you can see. Now, after getting this polygon, we are having actual cut section generated into your top. So now thereafter, we have cut and removed the top portion of your object. Now we should draw the remaining portion by a darker line, which will be our actual object after your cutting. So let us make the remaining object by a dark line. So we should make the remaining object by a dark line like this. Thereafter we know that in the front view, you know that you have cut and removed the top portion of your pyramid. So we should show the portion of your square pyramid just below your cutting plane by a darker line. So let us show the bottom portion of your pyramid just below your cutting plane by a darker line like this. So this is nothing but your cut section of your pyramid, square pyramid. So now then after what we should do? So let us try to find out the true shape of section. So we know that true shape is generated in what direction? Perpendicular direction to your cutting plane, right? So now it is very easy. So let us first find out our cutting plane's position. So this is our cutting plane. So we should draw lines 90 degrees to this cutting plane from your points 1, 2, 3, 4 because these are the points which are generated by cutting the plane. So here in our case, what we need to do, you should draw the perpendicular lines from your point 1 dash, 2 dash, 4 dash and 3 dash. So let us try to draw a perpendicular line from your 1 dash point. So we have drawn the perpendicular line from 1 dash point. Now then after what we should do? So we need to identify the true shape of the section for one number point. So what we should do? So let us suppose this cutting plane line is now your xy line. So what we should do? After drawing the perpendicular line from your 1 dash point, you should mark the very first point of the true shape of section on that line. So what you should do? So now take out your rounder and let us assume this inclined line or your cutting plane line as your xy line. Now put your rounder on your xy line, real xy line. Then after take the dimension of your point A from your xy line until your top view. After taking the dimension, you should put your rounder on intersection of your cutting plane and one's line there. And putting rounder, you should make one arc on this 1 dash line. You will get one new point generated, which will be nothing but your point 1, 1. First point of your true shape of section. Similarly, let us generate few more points. So let us draw a perpendicular line from your points 2 dash and 4 dash. Now, after that, what we should do? Take out your rounder once again. Now, put your rounder on your xy line and take the vertical distance of your points from your xy line. First, let us take the distance of 4 points from your xy line. And in second case, you should take the distance of your point 2 from your xy line. And by taking the distances on your rounders, now you should put your rounder on the intersection of your cutting plane and the line from your 2 dash and 4 dash line. By putting rounder at that place, you should mark these 2 points, which are first 4 dash point will give you point 41, and second point will be here. It will be what? It will be your point 21. So let us mark these 2 points 41 and 21 from this line. So this is your point 21. Then after what we should do? So then after let us draw a perpendicular line from your point 3 dash like this. We'll be following a similar course here. So now let us go to this xy line. So let us take the distance on your rounder from your xy line to your point 3 onto your top view. Thereafter we should go to your cutting plane line. Find out the intersection point of 3 dash and your section plane line somewhere there. And after that point, getting that point, you should put that rounder on that point. And you should mark your point 3,1 on that line somewhere like this. So you will be having your point 3,1 somewhere like this, and this will give you a point 3,1. After getting 1, 1, 2, 1, 3, 1 and 4, 1, so these are the end points of your true shape of section. You should simply connect these points by a straight dark line. So let us connect these points by a straight dark line. So this is nothing but a true shape of section generated while we try to move our object from 90 degree or perpendicular direction from your cutting plane. Right? Very easy. Now, after getting these views, as these are the section planes, so we know that sections are shown by a hatching line 45 degrees and which are at equal distance apart. So let us show the hatching line on the surfaces like this. On this surface as well as our bottom portion. So we'll be having our object generated. So now we should now move to our next and final point. So here it is said that find out the sectional side. So what we should do? So firstly we should construct an x1 y1 line, and onto the right hand side of your front view we'll be having our profile plane, and onto that plane we should try to generate our sectional side. So now let us try to generate our x1 y1 vertical line. This is nothing but your x1 y1 line. On the right hand side portion it will be now your profile plane. So now what we should do? So you should draw and transfer each and every point from your top view onto the right hand side of your x1 y1 line, and thereafter you should be taking on your rounder dimension from your center point to that point, and you should make the arc and you should transfer each and every point onto your xy line. So let us try to transfer point D. So you should have drawn one horizontal line from point D. Then after, let us take out a rounder. Put your rounder at the intersection point of x, y and x1, y1 line. Then after, take the radius from the intersection point until your point D onto your x1, y1 line. And then you should draw one arc. And then after, you will be having the point generated D double dash. D double dash is nothing but your side view. It can be generated by the intersection of point coming from this arc as well as from the horizontal line from your front view. So you will be having your point D double dash generated. So we know that on this arc your point is coming is what? Your point D, and on horizontal line from your front view you will be having point D dash coming. So by intersection of horizontal line of D dash and arc of your point D will give you D double dash. Similarly, transfer each and every point to first xy line. Then after, you should take the radius from intersection of your axis to your point C, and then you should transfer point C. And then after, you should transfer each and every point onto your xy line like this. After having all of the points generated on xy line, we should finally transfer our fx point. You should transfer fx point horizontally onto x1, y1 line. Then after, you should revolve this like this, and then you should draw this line. After drawing this line, you should draw a straight line from your fx point O dash in order to get your point O double dash generated. Now we are having each of the points. So let us connect each and every point to your fx points. So let us join the lines connecting to your fx point like this. Then after, we should just transfer the sectional points onto this line. So first let us transfer point number 3 dash by horizontal line. So let us transfer point 3 dash by horizontal line. Now we know that 3 point is coming from what? The C line from here. So the intersection of 3 point from the C line and intersection of this 3 dash point will be having our final point, which is nothing but what? 3 double dash. Similarly, we should transfer each and every point of our cutting plane, so which is 1 dash, 2 dash and 4 dash. So let us transfer each and every point horizontally like this, and then we should mark these points 2 double dash and here 4 double dash. So these points can be found by drawing the horizontal line from 4. Then after, you should make one arc and you should go up. You will be having a 4 double dash point. You should draw horizontal line from your point 2, and you should go and make one arc, and if you draw the vertical line, you will be having your point 2 double dash. Right? Then after, finally you should have your point number 1. So point number 1 is on AC line. So when the AC line goes up, and if you draw the horizontal line from your point number 1, you will be having your point 1 double dash generated somewhere here. So after getting all of these points, let us connect these points by a darker line. So let us connect these points. So we will be connecting all these points, and then after, we should just finish the object by a darker line. So this will be your final cut section into your side. The upper portion is obviously cut and removed, so this portion should be drawn lighter. Remember, you should keep in mind, you should keep that portion. You need not to drop that portion because it is the part of the construction, so you should always keep that top portion, so it should be as lightest as possible. Now then after, we should define this hidden line. So as we can see, we are taking the side view from the left hand side direction of your front view, then the line 3C would not be visible for our case, so we should make this line as a dotted line, and then after, as it is your cut section, you should specify the section cutting line on this section. So this is nothing but your section shown in your side view. That's why it is also known as your sectional side. So we have got each of the answers. This is your sectional top view, this is your sectional side view, this left one side is your true shape of a section. It is quite lengthy example, but if you practice more, you can solve this example within 15 minutes or so. So now let us see example number 2. A pentagonal pyramid base 30 mm side and axis 60 mm long is lying on one of its triangle faces on the edge with the axis parallel to the VP. A vertical section plane bisecting the top view of the axis and makes angle of 30 degree with the reference line. Cut the pyramid, remove its top part. Draw the top view, sectional front view and true shape of the section. So here we are talking about our element as a pentagonal pyramid. Once again, pyramid means we should remember Egypt's pyramid, so the shape would be like this, but the base here would be of a pentagon. It is said that it is resting on one of the triangular faces on HP, so we should put our pentagon in such a way that it should be having its triangular faces on HP, and then after we are having one cutting plane, so you should define that cutting plane, and after that you should proceed see the example for your front view, sectional front view, top view, and your true shape of a section. So now let us draw first our XY line like this. We will be drawing this XY line, and as we know, the portion just over your XY line is nothing but what VP, and the portion below your XY line would be your HP. So here we say that it should be having a triangular face on HP. So it says that you should start drawing a pentagon from HP itself. So let us put our pentagon in such a way that we should have a triangular face into HP. So how to draw the pentagon? We should put our pentagon in such a way that it's one of the sides or edges would be on the right hand side of your object. We should draw a pentagon like this. One of the edges should be on the right hand side. And if you can put a pentagon in such a manner, it is guaranteed that one of the triangular faces will be lying on the right hand side, or it is guaranteed that one of the triangular faces must be lying on HP. So let us draw a pentagon. So this will be the case of pentagon. After drawing the pentagon, you should find the center of your pyramid or the apex point. So you should draw a line from the corner point to the opposite side's midpoint. You should draw another line from any of the corner point connecting to the opposite side's midpoint like this. After getting this midpoint, you should mark this point as the apex point, and then after you should connect each and every point of your pentagonal pyramid to this apex point. After getting this apex point, you should give the location or numbering to this pyramid like A, B, C, D. So let us give numbering A, B, C, D, E, and center point as O. Then after we should draw vertical lines from each and every point. So we will be having our pentagonal pyramid today. So here we say that axis of pentagonal pyramid is 60 mm. So we should draw the axis line vertically from above your XY line as 60 mm. So let us draw vertical line from each and every point first, and let us define the points as A dash, B dash, B dash, and C dash, D dash. Then let us draw the vertical line from the point O, and the vertical line should be 60 mm from your XY line like this. And after having this vertical line, you should define that line as a center line or axis line. And after that, getting the top point as an O dash point, you should connect each and every point of the base to that O dash point like this. So let us connect each and every point of your base like this to your O dash point. So this is nothing but your front view of your pentagonal pyramid. Now let us observe. Is it the true position which I have placed my pentagon in HT? So let us check. So here in example we say that you should put the pentagon in such a way that one of its triangular faces must be resting in HT. So must be resting in HT, that means your pentagon will be in the HP itself but on the triangular face. So your triangular face must be on the right hand side while drawing your pentagon into HT. That must be the case. So here let us see. So here as you can see, now you can see one triangle generated by the DOC. So DOC is a triangle which is on the right hand side of the pentagon. So if your triangle is on the right hand side of the pentagon, it is guaranteed that we will put our pentagonal pyramid which is resting on its triangular faces. So this triangular face have generated the straight line here by these 3 points O dash, D dash, and C dash, which is nothing but known as your triangular face. So now we say that your triangular face is on HP. So we should select that triangular face O dash, C dash, and D dash. And we should place that triangular face somewhere here on your XY line. So if we can put this triangular face onto HT or onto XY line, then we can have a final condition which says that your triangular face must be on HT. On HT means on XY line. So we have put our triangular face onto HT. Now we should simply redraw our image from your first stage front view into this stage by putting your triangular face onto your XY line. So let us try to put our object now by O dash, C dash, D dash onto this horizontal line. Thereafter, by the help of your rounder, you should try to plot and regenerate your previous drawing into this. So this will be your final object. After getting this object, we should finally draw its top view from the top direction. So let us observe this object from the top direction. So when we try to observe the object from the top direction, we can have vertical lines of projection like this from each of the points as you can see, and from the horizontal lines from the previous points. And then we should define the points of intersection like A, B, C, D, E. And then after finally we will be defining your apex point somewhere here. After getting this point, you should connect the point or outer boundary surfaces, and you should join each and every point. So let us join each and every point in order to complete the pentagon. But here, let us try to visualize. if any element which is missing or which is hidden by taking the top view. So let us try to observe. So when we try to take the top view, so it is obvious that O dash point is clearly seen, completely base is completely seen. So each of the points of the base is completely seen, but there is one surface which is hidden from your observer, which would be your triangle face itself, O dash, C dash, T dash, because it comes under your object, so it can't be seen by taking its top view. So that means line connecting your O dash C dash and O dash D dash in the next view, that means the top view, must be your hidden line or dotted line. So let us put these lines OC and OD as dotted lines because it can be visible by taking its top view from this top direction. So we have drawn these two lines as hidden line. Right? Very easy. Now we have drawn our object by said position. So now we should apply the cutting planes now. So here it is said that it is cut by a vertical section plane bisecting the top view of the axis. So this is your top view. So top view of the axis means this line OA line. So you should bisect this OA line somewhere. So you should bisect the axis line. So you should first mark the point of axis. So first let us mark the point of axis first. So here it is said that in the example, let us read the equation. It is said that you should have a vertical section plane cutting in such a way that it is cutting the top view of the axis, and it is said that it bisects the top view of an axis and it is at 30 degrees with the reference line. So this is your top view. So let us find out first the axis of your object. We should transfer the point of axis and point onto your lines. This will be the total dimension of your axis, O till that pink line. And we should bisect this line. So let us find out and show the midpoint of this line like this. We will be showing the midpoint of this line like this. So this is nothing but the bisecting point of your axis line. From this line, we should construct one line which should be at 30 degree to the XY line. So we have constructed this line at 30 degree to XY line. And this line is nothing but what? Your cutting plane line. So we should show this cutting plane line by a spatial manner by making this end point in a darker. So this is now our actual cutting plane line. Now after observing this cutting plane line, we should give the numbering to this cutting plane as we have given in our previous example. So let us start giving the numbering. So we should start from number 1 from first alphabetical letter A. So let us see here the line cuts to a line OA. So let us give number 1 there. Then after we should go to point B. So here we will be having point number 2. Then after we should go to 3 point, we will be having 3. Then D point we will be having 4. Then after point D we should be looking for point D. So let us find out this point number 5 here. After getting point 5, we should now return back because the point D is reached. So let us go back. So we should find out the point D. So we will be having this line OD, which is the back of the object. So we will be having point number 6. So these are the total complete number of points in which your cutting plane line is cutting your object. Very simple. You should just simply transfer each of the points from this object to this front view because we need to show the effect of your cutting plane into your front view, right? So let us transfer each of the points on the corresponding line. So that means if the point this one is on OA line, we should transfer this point 1 on the O dash A dash line in this view. If the point this is 2 on the OB line, then we should transfer this point vertically onto the O dash B dash line. So we should similarly transfer each and every point onto their corresponding lines. And after transferring each and every point to your corresponding lines, we should try to join these points by we should give the numbering like this: 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. So we will be able to complete object generated. So let us observe, we have transferred this point 1 onto this OA line somewhere here. Then after we have transferred this point 2 on OB line somewhere there. So we should transfer each of the points vertically up to that line, corresponding line. And after getting this point, we should locate this point by 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. And then after we should connect all these points by a darker line. We have this cut section generated, which is nothing but our final. After having the final, we should make the object on the left hand side of this cutting plane darker. And we should make the object after this cutting plane. So this is the remaining object with us after the cutting plane. So we should make that object darker, and we should show the hatching line into the section like this. Let us make this hatching line in the section. We should make this object darker on the left hand side of the cutting plane like this. Let us make this section darker. So it is showing that we are remaining with this object with us after cutting the object, and we should show this object by a darker line. This is nothing but how you should draw your object. So the lighter portion is showing that we have just removed that portion. We are left with the portion which is shown by the dark line. It is very much easy. Now let's come to the last and final point. Here it is said that you should find out the true shape of section. So how to find out the true shape of section? So here we should draw lines perpendicular to this line or cutting plane line, and we can find out the true shape of section. But now let us see a different method. We will not be directly drawing the perpendicular lines from your cutting plane line, but rather we will try to generate one parallel line parallel to a cutting plane line outside your surface of your plane, and from that line we will be generating a perpendicular line. So let us draw one line parallel to this line, and this will be your new line. So in the place of drawing the perpendicular lines from your cutting plane, we are actually drawing one line parallel to the cutting plane line, and from that line we will try to generate a perpendicular lines. So now what we need to do? So let us try to generate the perpendicular lines from each and every points from your cutting plane line like this. And so now let us start the process. So let us first define the point 3 dash. So we know that point 3 dash. So here we know that point 3 dash is onto the xy line itself. So let us define point 3 onto the xy line like this. Then the point 4 dash is also on the xy line. So we will be defining here point 4. Then let us define point number 2. For defining point number 2, what we need to do? So we need to take the dimension of your point 2 from your xy line, and we should plot that point 2 here. So you will be having your point 2 somewhere here generated. Thereafter let us plot point number 1 dimension. So what you should do? You should take the dimension of point number 1 from your xy line on your rounder, and you should put your rounder here, and you will be having your point 1 generated somewhere here. So this will be point 1. Now let us plot point number 6 first. So you should take the dimension of point number 6 from your xy line, and you should put point number 6 dimension here. So you will be having your point 6 generated there. And thereafter finally you should take the dimension of point number 5 into your rounder from your xy line, and you should put your rounder on this inclined line, and you should plot this point. So you will be having your final dimension generated. After getting all the dimensions, you should simply join these points by 1, 2, 3, 4 numerical manner, and you should give this pattern. This is known as hatching. So we have provided hatching. This is nothing but your true shape of section generated. Very easy. So what we have done, once again, I will quickly revise. You should draw a line parallel to this cutting plane line like this, and now you should draw the perpendicular lines from each and every point on your cutting plane line. Then after, you should assume that this parallel line is nothing but your xy line in our case, and you should take the dimension of each and every point onto xy line, and you will be putting that same dimension with respect to your this new parallel line. So let us suppose 3, 4 points are on xy line, so we should be specifying 3, 4 points. Then after, we should select on your rounder from xy line till 2 distance, and this is your new xy line. So from there, you should take the distance here. Then you should take range of the distance from the xy line from your O figure, and you should put that dimension just below this line, and you will be having your true shape of section generated. Very easy. Let us move to the next example. Let us see example number 3. A hexagonal prism has a face on the HP, and the axis is parallel to the VP. It is cut by a vertical section plane which makes an angle 45 degrees with XY line, which cuts the axis at a point 20 mm from one of its ends. Draw its sectional front view and the true shape of the section. And side of base is 25 mm long and height is 65 mm. So here the hexagonal prism is given. So prism means, let us remember prism. Prism is having two of its base, top base and bottom base of the similar shape and size. It is connected by a vertical line, and it is having a rectangular face on its sides, right? It is known as your prism. So here your base and top will be of hexagon. So it is said that the dimensions are given at the end of your example. The dimension of prisms are given. It is said that it is cut by a vertical section plane. So vertical section plane is nothing but your AVP, making a certain angle with your vertical plane. So here is your vertical section plane. So now we will be cutting our object by vertical section plane. So we should be drawing sectional front view and true shape of the section. So let us start. So first let us draw our xy line once again. So this is nothing but your xy line. Above portion is VP and below portion is known as HT. So you should draw the hexagon in this manner. Now after drawing the hexagon, let us define the dimension of the hexagon as 25 mm. After that, you should give the number into hexagon like ABCD. So let us give the numbering. Then after we should draw the vertical lines from each and every point in order to have your front view generated into V. So here the height of the hexagon is said as 65. So you should generate one rectangular box just above each of the points by drawing the vertical lines from each and every point, and we should be having this rectangular box. After having the rectangular box, we should specify each of the points by drawing the vertical lines from each and every point. So let us specify the first line as A dash A dash, second line as B dash B dash, and third line as C dash C dash. Then after we should come back, we should define this line as D dash D dash, then E dash E dash, and then F dash F dash. So this is nothing but an hexagonal related, and always remember, hexagonal prism has two of its edges superimposed or coinciding each other, so we'll be having a double dimension to its sides, the top face and the bottom face dimensions. Now, in second phase, it is said that it is resting on its one of the rectangular faces. So we know that the rectangle means for it is an element having the four sides. So here let us see on the right hand side of the hexagon we are having one side which is having a total of 4 points. So that means that this side is nothing but what? The rectangular face of an hexagonal prism. So, as you can see, this vertical line is consisting of a total of 4 points. That means this line represents your rectangular face. And if you need to represent your rectangular face in your front view, you should obviously draw an hexagon in such a way that you should have this vertical line on the right hand side. So now let us put this vertical line of C dash C dash and E dash D dash onto this horizontal XY line. So let us put this object like this. We will be putting these objects. We will be having our final object something like this. So this is nothing but your hexagonal prism front view drawn in the same position in which your rectangular face is now on your XY line. After having this object, you should draw its top view. So let us draw a vertical line from each and every point, horizontal line from your previous drawn image, and you will be having our final object generated, which is nothing but what? Your required hexagonal prism into the top. Now, what we should do? The next task is to place our cutting plane. So we said that we is having a vertical section plane. So vertical section plane is making a certain degree angle 45 degree with the XY line. So vertical section means it is your AVP making an angle with your vertical plane. It is known as your vertical section plane. So if this is XY line and this above this line is your VP, then angle made with VP would be line below this XY line. So let us make an angle at 45 degree, and here it is passing from the 20 mm away from one of the base. We should take 20 mm away one point. So let us first define one point, which is nothing but your point, which is 20 mm away from your base. And now you should draw a line which is passing from that line, and we should be at 45 degree with your XY line. Right? So this is nothing but our cutting line. Then after having this cutting plane line, we should have the points marked on this line. So you should remember how to mark this point. So let us see the procedure how to mark these points on the cutting plane line. So now let us understand how I will mark this point on this cutting plane line. So we should start alphabetically first. We should start with this point. So first AD. So this line cuts this AD. So we should specify this point as 1. Similarly, after B, point C comes. So here as you can see, point B and C are here. So it is also cutting your BC. So we should give point number 2 here. After point C, we should have this line somewhere here. So it is cutting this line. So this is line your AC line. So here we are on point C. So we should be focusing on CC line. So it is cutting your CC line. So we should point number 3. After point C, it is cutting your D line. So we should give point number 4 to your D line. Then after we should go to E line and we should give final point. After E, we should be coming back to F and we should give on this FF line point number 6. And after this FF line, once again you are coming to your point A, so you are coming to your point AA line and you should give your point number 7. So once again, AD you will be having point 1, BC point 2, CC point 3, DD point 4, EE point 5, FF point 6, and then once again AA point 7. So after defining all of the points, so now let us make the left hand side portion of your object diagram, because we are doing this right hand side portion of your object. So let us make the left hand side portion on the cutting plane line a diagram like this. So we will be making this portion on the left hand side of your cutting plane will be making this portion dark. Therefore, we should transfer each and every point onto these vertical lines. We should identify and mark the points, corresponding points on this line like this. So these are nothing but our required points, and you should connect these points. So how to transfer these points? You know that this point is on, one point is on AD line. You should take the distance from your point B. You should mark that point in such a way that you will be having these points. So after having these points, corresponding points on corresponding lines, you should connect the object by a darker line. So you will be having your final object generated, which is nothing but what? A required hexagonal prism. Here I have drawn this line with the dotted line because when we try to take the front view from this direction, it is obvious that this BB line will not be seen. So we should put that BB line as your real line. So I have put this dotted line here. But here, as you can see, there is a solid line on the left hand side because it is superimposing a line of E. So here BB and E line coinciding each other. But here in the cut section, we are not having any E lines. We can specify this dotted line. But here we are having point E and solid lines. We should plot that solid line. So always remember when you try to join the points, and if you are having the dotted line and solid line at the same time, you should give preference to a solid line. So in this case, we have drawn this solid line darker, and this is your dotted line. After that, you should give the section lines in this plane. So this is nothing but your final view generated, and this is nothing but your sectional front view because section is seen in the front view itself, right? So now let us find out the true shape of section. So what we should do? So let us follow the process step by step. So we should be drawing the line parallel to this line like this. Therefore, we should draw the perpendicular lines from each and every points like this. So let us draw perpendicular lines from each and every points. Then we should specify the points with respect to these parallel lines onto this image in order to create your true shape of section. So this is, let us consider this as your XY line now. So this is your real XY line. So this XY line is now placed at certain angles. So this is now your XY line. So you should transfer each and every point with respect to XY line here. So now let us start transferring the points with respect to this XY line. So we can see that there are 3 dash and 4 dash point on XY line itself. So we should put 3 dash and 4 dash point onto this X1 Y1 line respectively. So let us put 3 dash and 4 dash point onto X1 Y1 line respectively. Now to find out point 1. So you should take the dimension of point 1 from here, and you should take the dimension from XY line here. You should put your rounders somewhere here, and you should take the dimension of your point 1 here from your X1 Y1 line. So you will be having point 1. Then after point 7, so let us take the dimension of point 7 from this XY line, and you should put the dimension here. You will be having your point 7 like this from this XY line. Then you should take each of the point from respected XY line above this XY line, and you should put the dimension just below this XY line onto your perpendicular lines on the respected point. So you will be having this final point generated like this. And after having this point, you should connect these points by a dark smooth line. This is nothing but your true shape. So after that, getting to the true shape, you should give the hatching to this true shape. So let us give hatching. So this is nothing but your final view generated, which is your true shape of the section. So we have generated sectional front view and true shape of the section. So now let us move to our next example. Example number 4. A cone with a base 75 mm diameter and axis 80 mm long is resting on its base on edge. It is cut by a section plane perpendicular to VP and inclined at 45 degree west and cutting the axis at 0.35 mm away from the apex. Draw the front view, sectional top view, sectional side view, and the true shape of the section. So here we are given one object with a cone. So we know that cone is a group B element which has one base, as a circular base, and which is having an apex point. So we should be having the dimension of cone which are given to us. It is cut by a plane in such a way that it is inclined at 45 degree to HP. That means your plane is inclined to HP, means your plane is auxiliary inclined plane, AIP. You will be using AIP plane. Thereafter you should be finding the views, front view, sectional top view and sectional side, and thereafter true shape of the section. So let us start by drawing the cone first. So let us first construct our XY line. So let us draw our XY line. Above portion is VP obviously, and below portion is known as HT. Then we say that the cone is resting on its base onto HT. So we should draw the circle onto the HT first below the XY line. So let us draw the circle below the XY line like this. After having this circle, we should divide this circle into some number of parts like this, and we should draw vertical lines from each and every point to create a front view just above the XY line. After that, you should transfer each and every point onto XY line, and since it is your front view, you should be transferring each and every point with the dash numbers and the top point also with the dash number. So if this is the O point, then you should specify the top point as O dash point. So this is our front view of the cone, required cone. So the height of the cone would be 80 mm axis height, and the diameter of the cone is 75. So you should draw the diameter of the circle. Then after what we should do? So it is said that it is cut by a section plane perpendicular to VP 45 degree to HP, cutting at the axis at 35 mm from the apex. So we should plot one point which is 35 mm from the apex like this. And this is the point from which we should draw one line which must be 45 degree to HP. So let us draw one line. So this is nothing but a cutting plane line, as it is said 35 mm from apex and it is making 45 degrees. Then after we should transfer each and every point onto this cutting plane onto your top view. So let us transfer each and every point down there. Then after we know that if the point is on the vertical line of O dash, O dash and O dash 10 dash, we should first transfer it to the one inclined line on the left, and we should transfer it vertically downward. And by using the rounder, you should transfer this point to O4 and O10, which are the vertical lines. So like this. Then after we should transfer remaining points from your section cutting plane to your top view of the circle, and then after we should identify these points and connect these points, it will give you this kind of object, which is nothing but the cut section in the top view. After having this cut section generated into the top view, you should draw the remaining portion just below your cutting plane in a darker like this, and then after you should show in the top view also the remaining portion by darker line like this. Therefore, you should give the number into each of the points on the cutting plane as well as on the top view like this. So these are the final points of your object. Then after let us move ahead, let us try to plot a true shape of the section. So you should be drawing the line perpendicular from your cutting plane, and you will be plotting the true shape of the section. So let us try to plot the perpendicular lines from this cutting plane, and on these lines let us try to mark each and every point on the cutting plane in order to get the true shape of the section. Let us draw the perpendicular lines first. Then after let us first mark this point A. So you should be taking the distance from your XY line until your A onto your rounder. And you should put that distance on the A dash line, and you will be having your point A1. Thereafter similarly you should take the distance of your point B, and you should be taking the distance from your XY line. You can similarly generate point B. And similarly you should follow the same process. You should take the dimension of each of the points from this XY line and below this object, and you should put the dimension from your cutting plane line onto the respective line in a O direction. You can have the different points generated like this, and after getting these points generated, you should just simply connect these points in order to have your final object generated. This is nothing but a true shape of the section generated. So this is nothing but a true shape of section, and this is what a sectional top. Then after you should draw the vertical line in order to get your side view. So this is your vertical line x1, y1, and on the right hand side this will be your profile plane. So let us transfer each and every point from your circle onto the right hand side, and we should be transferring your points horizontally in order to have the side view. So now what we should do? So you should transfer each and every point on the right hand side onto your x1, y1 line, and you should be transferring each and every point by taking your radius from the center point, making the arc. So you will be having each of the point transferred onto your xy line on the right hand side onto your profile plane or in the side. After having this point, what you should do? You should just extend the line of your axis. You should draw horizontal line from your axis in order to get the O double dash. After that, you should connect each and every point to your axis. So it will define your cone in the side. Thereafter, you should transfer the points from your section plane onto the side view in order to have the effect of section plane generated into the side view. Let us draw horizontal line from each and every points here, and let us find out each and every points on this side view. We will be joining these points in order to get the side view generated. After having this side view, you should make the below portion of the side view a darker, so you will be having this final view generated. Therefore, you should be providing a section to each of the drawings here. So this will be your final views generated. This is nothing but your sectional side view. This is sectional top view, and the final left hand side will be a true shape of the section. So this is the example of cone. You will be having three views. This is your sectional side view, sectional top view, and this is your true shape of the section. It is time consuming, so try to practice this kind of examples more. So remember the process, and you should practice 2 or 3 more examples, and you can master this chapter very easily. So that is all from my side. If you have enjoyed my lecture and teaching style, do not forget to like, share and subscribe to my channel. If you have any queries, any doubts, feel free and comment down below. Keep learning, stay connected. Bye bye.